Alright, welcome back. Let's talk about section 10.6, the derivative and algebraic viewpoint, and this is going to be a lot easier than the last section. Hopefully, I'm not going to dawdle as much. I don't want to rush through this, but remember, you can always pause when you need to, rewind. That's the beauty of a video lecture instead of asking me what I just said, because in the classroom, I will frequently tell you, I have no idea. Okay, so the definition of the derivative from the last section allows us to compute the derivative algebraically without having to estimate with tables or graphs. In fact, we've already done it. I'll show you. Let's check it out. Let's let f of x be 3x squared minus 4. We're going to find f prime of 2. Why 2? Why not? Whatever. We could find f prime of x in general. So I'm going to find f prime of 2 here in blue. And then in general, I'm going to move it to green. All right, so first part, find f prime of 2. I know that f prime of 2 is the limit as h approaches 0 of f of 2 plus h minus f of 2 all over h. Always. This is my limit definition of the derivative. This is always where I start when it tells me to find the derivative. Now, the limit as h approaches 0 stays there until we actually let h go to 0. So what is f of 2 plus h? Well, everywhere I see an x, I replace it with 2 plus h. I'm going to throw up some very light colored parentheses. So this is f of 2 plus h minus f of 2. Okay. So 3 times 2 plus h squared minus 4 minus 3 times 2 squared minus 4. We're going to simplify everything. 2 plus h all squared. 4 plus 4h plus h squared, still have the 3 times in front, and then minus 4 in back. Here we have 2 squared is 4. 4 times 3 is 12. 12 minus 4 is 8. All right, so we have a minus 8. We still have our 2 plus h function here. All over h still. More simplifying to do, we'll distribute our 3. So we'll have 12 plus 12h plus 3h squared, minus 4 minus 8, those values that were still there. Negative 4 and negative 8, those make 12, negative 12, and we have a positive 12, so they cancel out. I'm left with a plus 12h and a plus 3h all over h squared, just like we did last time. We're going to factor out an h. I don't know why I keep writing this plus 12, but I do. H's cancel out. Now the limit as h approaches 0 of 12 plus 3h. We could finally evaluate the limit. The reason we didn't evaluate the limit up here, excuse me, and I didn't really mention it, we can't have a 0 in the denominator. As long as we have an h in the denominator and h is going to 0, we have to just keep simplifying until we get there. So I simplified until I no longer have an h in the denominator, so the h going to 0 won't be a problem. When I substitute h going to 0, I'll have 12 plus 3 times 0, which is 12. And so if we start at the beginning, f prime of 2, all of these things are equal. So f prime of 2 is equal to 12. Okay, now in general, we want to find f prime of x. So in order to find f prime of x, I'm going to do a couple of things first. The first thing we're going to do, what's the hardest part? It's always this stuff here in parentheses, right? It's the f of x plus h. So I'm going to find that just on scratch paper first. All right, I'm going to put it right here, just that. X plus, what is this function? 3x squared minus 4. I want f of x plus h. That's 3 of x plus h squared minus 4. I find x plus h squared. Remember, always FOIL it. Don't just square h and square x. You have that middle term. Distribute. The second thing I'm going to do, I don't know why I put a 1 there when it's clearly already right there. Now, my second thing to do is the entire numerator. I take this answer, and then I subtract f of x. So I have my answer from the left side, right, minus the original function. So I'll distribute the negative, which changes that to a plus. Check it out. I have 3x squared and a minus 3x squared. I have a minus 4, I have a plus 4. Everything that remains has an h in it. So my preliminary work always, and this is how I do all my derivatives now, at least in classrooms. I'm going to find f of x plus h. Then I'll find f of x plus h minus f of x. Now I don't have to write the limit that many times and probably forget it along the way. I could write the definition, f prime of x is the limit as h approaches 0 of f of x plus h minus f of x all over h. And I know what that is. I already know what that whole numerator is when in simplified version. Limit as h approaches 0 of 6xh plus 3h squared over h. Factor out an h and cancel. Still the limit because I haven't put 0 in for h yet. Limit as h approaches 0 of 6x plus 3h. Now I'll put h is 0 and I'll get 6x. So I have a function. Now this is just a function that behaves like any other function, right? We know all about this function. Notice that with this formula, I can still find f prime of 2 is 12, like I did up here, but I could also find f prime of 5 is 30. F prime of negative 3 is negative 18. I can find so many more because I have a function for the output to find the derivative instead of having to do this for every single x value. And that, my friends, is the algebraic viewpoint. Let's do more examples. We're going to compute f prime of a algebraically. We're going to start with a nice linear function. F of x is negative 2x plus 4, a value at negative 1. So remember, all right, f prime of a is the limit as h approaches 0 of f of a plus h minus f of a all over h. I'm finding f prime of a specific value given to me. Here we go. So f prime of negative 1 is the limit as h approaches 0 of f of negative 1 plus h minus f of negative 1 all over h. Let's find those pieces. I'm going to do the first piece, f of negative 1 plus h, here in green. So that's a negative 2 times a negative 1 plus h plus 4. Distribute, I'll have 2 minus 2h plus 4, which is 6 minus 2h. I'll find f of negative 1, right, the a value, f of negative 1, by substituting negative 1 for x. Negative 2 times negative 1 is 2. 2 plus 4 is 6. Now I can substitute, right? I know these pieces. I did my work on the side instead of inside the limit. So the limit as h approaches 0 of f of negative 1 plus h, here in green, minus f of negative 1, here in gray, all over h. 6's cancel out. I end up with the limit as h approaches 0 of negative 2h over h. H's cancel out. I get the limit as h approaches 0 of negative 2. But you see, negative 2 doesn't care what h does. H can do whatever, excuse me, whatever it wants. And it's always going to be negative 2, right? So f prime of negative 1 equals negative 2. But also, check it out. What is this? The derivative is just the slope. What's the slope of the tangent line at negative 1? Well, this is a linear function. Its derivative at every point is going to be negative 2 because it's already a line. So if I want to estimate with a line, with a slope, a line, it's going to be the same line. It is its own tangent line. It is its own slope at every moment. All right, number 2, something a little more challenging. I just like to show kind of those basic or simplistic ones, not because they're easy, but the fanciness of a slope of a tangent line holds with what we know to be the slope of the line. And that's important that these higher concepts jive with what we've got going in our earlier concepts. Number 2, f of x equals 2x squared plus x. Our a value is negative 2. Now I know I'm going to need f of negative 2 plus h, and I'm going to need f of negative 2, so I just start with that. I find f of negative 2 plus h by replacing every single x with an open parenthesis, and then I fill it in with negative 2 plus h. So I'll have 2 times negative 2 plus h squared plus negative 2 plus h. Simplify, right? First I do my square. Since I'm adding, I don't need parentheses here. Now I distribute my 2. 2 times 4 is 8. 2 times a minus 4h is a negative 8h. 2h squared minus 2 plus h. 8 minus 2 is 6. Negative 8h and a positive h makes a negative 7h and a 2h squared. Wow. So I found f of negative 2 plus h. Here's the easy part. Let's find f of negative 2, right? That's my favorite part to find, actually, is the easier one. Substitute negative 2. There's a whole lot of 2's going into this one. I should have used a different a value. I apologize. Negative 2 squared is 4. 4 times 2 is 8. 8 minus 2 is 6. Here's a little tip. These numbers should always match up. And when you do this step, it's nice to have little checks along the way. Where did I mess up if I messed up? You don't want to find out when you enter an answer in your homework and it tells you you're wrong. Trash truck's coming back through. But they went outside this time. We're good. Okay. Yeah, so if you listen to 10.5 and 10.6 back to back, you could time how long it takes for my trash truck to make its round down the street and back up the other side. Now that I have my pieces, I know that f prime of negative 2 is the limit as h approaches 0 of f of negative 2 plus h minus f of negative 2 over h. I always start with the definition. I always remind myself of the definition. And then I fill in my values. The limit as h approaches 0 of 6 minus 7h plus 2h squared minus f of negative 2 all over h. 6's cancel out. I have the limit as h approaches 0 of negative 7h plus 2h squared over h. So we factor in h from the numerator, still have our limit, cancel our h's, still have our limit. Limit as h approaches 0 of negative 7 plus 2h. Now that I no longer have an h in the denominator, I don't have to worry about a 0 in the denominator, I can evaluate. Negative 7 plus 2 times 0 is negative 7. So I found the derivative at negative 2 to have a slope of negative 7. A rough sketch. This is a quadratic of some sort. More or less. And so what we're saying is over here at negative 2, this slope is negative 7. It seems reasonable. With a quick and dirty sketch anyway. All right. Now instead of f prime of a, let's find f prime of x algebraically. Same idea. So I'm going to start with first find f of x plus h. So everywhere I see an x, I turn it into an x plus h inside of parentheses. So x plus h minus x plus h all squared. I did the squaring. I left the parentheses though, so I remembered to distribute my negative. Now when I combine, nothing combines here, by the way. When you expand f of x plus h, frequently you will have nothing that combines. Not always, but frequently. And nearly always, now that I think about it. The second part, I want the entire numerator, right? My entire f of x plus h minus f of x. I have my f of x plus h. That's here. I subtract the original function. Distribute my negative sign is the only thing I did here to make sure we get the positive. I have an x. I have a negative x. I have a negative x squared. I have a positive x squared. All those x's that have no h's with them, they cancel out. That's your next, that's a good check too. Like these 6's will always match up. Here in this step, in step 2, you should have nothing that doesn't have an h, right? We have h minus 2xh minus h squared. Everything has an h, so let's take that h out, factor it. H divided by h is 1. Minus 2xh divided by h is a minus 2x. And a minus h squared divided by h is minus h. Now I could pop it right in over here. Right? I've done my side work. I've built it up. So f prime of x is the limit as h approaches 0 of f of x plus h minus f of x all over h. I always write the definition. Fill in what I know. I know my numerator is h times 1 minus 2x minus h. It looks like a u, but it's an h. Divided by h. H is canceled. The limit as h approaches 0 of 1 minus 2x minus h. So now finally I can let this h go to 0 and I'll get 1 minus 2x. So the derivative is 1 minus 2x. F prime of x is 1 minus 2x if f of x is x minus x squared. All right, more examples. Looking at number 2, we're going to find f prime of x again. Right? F prime of x is always the limit as h approaches 0 of f of x plus h minus f of x all over h. This is where I start, always. That's the setup anytime I want to find a derivative with the definition. So I do the prelim work, f of x plus h. Feel free to hit pause if you want to check that and make sure that it's exactly as I say it is. So step 1. Step 2, find the entire numerator. Now I'll take this answer, right, all of this, and I want to subtract the x and I want to subtract a negative 2x cubed, so that's add a 2x cubed. And everything I have left is just the h's. Okay, so I didn't actually write the subtraction, I wrote the result of the subtraction. Just by seeing that I'm going to subtract an x and I'm going to subtract a negative or add a 2x cubed. Factor out my h because everything remaining has an h in it. Yes, that squared is correct here. It should not be there. So now, I can find the limit as h approaches 0 of my numerator divided by h. That's where my h's cancel. Limit as h approaches 0 of 1 minus 6x squared minus 6xh minus 2h squared. When h goes to 0, I'll just put 0 in for every h, right? Algebraically evaluate a limit by substituting. And I get 1 minus 6x squared as my function. Those go to 0, and what remains is 1 minus 6x squared. All right, last example of this type. F of x is 2 over x. Now, this gets a little tricky, all right? Polynomials are awesome, but we're not always going to give you polynomials. Sometimes you can have rational functions or even radicals with square roots. So we start again. First step, find f of x plus h. Bummer, not much to do. When there's nothing to simplify on your first step, be scared because the second step is going to be harder. Sometimes the first step is the algebra. Sometimes the second step is the algebra. So here in f of x plus h minus f of x equals 2 over x plus h minus 2 over x, I ask myself, how can I simplify this? Well, in order to add or subtract fractions, I need a common denominator. So I multiply this first fraction by x over x, and I multiply the second fraction by x plus h over x plus h, because now both denominators will be x times x plus h, and we could deal with the numerators. So 2x minus sign, 2 times x plus h. Now that we have a common denominator, I can combine the numerators. 2x minus gets distributed, so it's a minus 2x and a minus 2h, right? That minus 2 goes to both the x and the h. 2x and a minus 2x cancel out, and I have a minus 2h. Fantastic. Now, I've simplified, right? That's all I could do. I made them into a single fraction. Let's see what happens. F prime of x is the limit as h approaches 0 of f of x plus h minus f of x all over h, no matter what your function is. In this particular case, I've found my numerator. So limit as h approaches 0 of negative 2h over x times x plus h, all divided by h. Remember, this h is that h. But if I divide by h, it's the same as multiplying by 1 over h. So when I change this division to multiplication by the reciprocal, notice now my h's cancel out. And I'll have negative 2 over x times x plus h. And you're thinking to yourself, yeah, but I still have an h in this denominator. Check it out. What happens when I put in a 0 for h? It's not the entire denominator anymore. There's other stuff going on. So when I have x times x plus 0, that's just x squared in the denominator. I'll have a negative 2 over x squared as my derivative. Hold on while I go visit with my dog. Nice friendly chat. I love my dog, actually. That's the worst part, is it's my dog out of the 4 that we have that is the loudest, and so she's special. Okay, find the equation of the tangent line to the graph at the indicated point. Equation of the tangent line. It's a line. Equation of the tangent. It's always a line. What's the equation of a line? Equation of a line is y equals mx plus b. Another equation of a line that is much better for calculus is called the point slope form of a line. Y minus y1 equals m times x minus x1. But what we really know is that if x1 is a, then y1 must be f of a. And what's the slope? Instantaneous rate of change is the slope. The derivative is the slope. So if we take this normal line that we know the equation of, because we saw it in Math 1320, or similar course if you're from a different university transfer, we know how to do this with functions. Cool. We could do this. Find the equation of the tangent to the graph at a given point. F of x equals x squared plus 1 when a equals 2. Here's how I've broken it apart. First, equation of the tangent I know has to use a derivative, And if there's a derivative involved, I'm going to be using the limit as x approaches infinity. The limit as h approaches 0 of f of x plus h minus f of x all over h. So I might as well find my f of 2 plus h, all right, which is 2 plus h all squared plus 1. Square that out, add 1, we'll get 5 plus 4h plus h squared. I also need an f of 2, right? So I need at the indicated point, I'm looking at f of 2 plus h minus f of 2 all over h, right? So we'll find f of 2, that's 2 squared plus 1, excuse me, equal sign, 4 plus 1, which is 5. Now I found f of 2, that's my a value, that's 5. I still need to find my derivative, f prime of 2 is the limit as h approaches 0 of 5 plus 4h plus h squared minus 5, so the 5's cancel out. We can factor out our h's that are remaining. Well, the limit as h approaches 0 of 4 plus h, and when h goes to 0, this becomes 4. So I have my y value, I have my slope value, and I'm given my x value, a, excuse me. So I substitute y minus 5 equals the derivative of 4 times x minus 2. I'm a big fan of taking this, depending on what it looks like on your online answer box. Unless it says simplify, why not just add this 5 to the other side? You could totally simplify, right? Write a y equals mx plus b form, but you don't have to. This is an equivalent form, and this is a great answer. So if you want to take the point slope equation and then just solve for y without distributing, that's also equivalent and tells us some good information, as it turns out. This is the format that we use frequently in linearization in approximations at calculus at a higher level. This one's a little long again, and it's just because of all the words that I have to say to tell you all the writing that we're doing. We've got this, right? F of x equals x squared plus x when a equals negative 1. I start out, I still want the equation of the tangent line, instructions on the previous page. So I'm going to use the same idea. Y minus f of a equals f prime of a times x minus a. This is the equation that we're going to use anytime it asks for the equation of the tangent. It's always the equation of a line. So I find my pieces. F of negative 1 plus h, negative 1 plus h squared plus negative 1 plus h. Simplify. All right, minus, because I'm still looking at f of negative 1 plus h minus f of negative 1 all over h. Limit as h approaches 0. So I find f of negative 1. Negative 1 squared plus a negative 1, that's 1 minus 1, which is 0. I love zeros. Notice how when we simplified f of negative 1 plus h, it didn't have any constant terms. And this constant term is 0. It matches, right? All we're left with are h's. Nice. H factors out. H cancels. The limit as h approaches 0 of h minus 1 is 0 minus 1, which is a negative 1. So in blue, I have my negative 1. In green, I have my 0, my y value. My negative 1 for a was given to me here. So x minus a negative 1 is x plus 1. You could leave it actually at either one of these stages, last two stages. This one I'd probably simplify just because there's very little chance of me to screw it up. The other one I have to multiply and add and do a whole bunch of other things. All right, last problem of the section. If a stone is thrown down at 120 feet per second from a height of 1,000 feet, its height after t seconds is given by s of t equals 1,000 minus 120t minus 16t squared. We've had a couple of these. Height stays by itself. Velocity, right? It's thrown down. It's the rate it's going. So since it's thrown down, it's negative. Speed, 120 times t. Feet per second, so we multiply by the number of seconds. And this is due to gravity. Right? This is based on the rock. This is based on the earth. We want to find its instantaneous velocity function and its velocity at time t equals 3. So instantaneous velocity function, that's just a fancy way of saying, hey, find the derivative. But we know the velocity is the derivative of position, which is the limit as h approaches 0 of f of t plus h minus s of t all over h. And we can find those values. S of t plus h, when we substitute t plus h, everywhere we see a t, right? Take it slow, take it step by step, distribute, make sure you keep that negative sign straight. And then, let me see, and then we're going to subtract the original function. So here I'm going to subtract the 100. I'll subtract a negative 120, so I'll add 120t. And I'll subtract a negative 16t, so I'll add a 16t squared. That's a squared. So everything that doesn't have an h in it at the end of the first step is exactly what's in the function, which is exactly what we're subtracting off. We're subtracting off the original function. We're left with just the values that have the h's. When we factor out our h's, right? Factor out the h for the numerator, cancels the h in the denominator. As h goes to 0, I substitute h value of 0. I'll end up with my velocity function. The velocity is negative 120 minus 32t. So that's the first part of our function. Find its velocity at time t equals 3. Now we could have did one of these and started reinventing the wheel again. Right, do the whole process over. That's valid. But we just found the function for the velocity. Why not just substitute 3 and find the answer to be negative 216 feet per second? It's velocity, 216 feet per second, headed in a downward motion. If you do this, do all the algebra, you can end up with the same number. We do it in general so that we have a function in case we want to evaluate at many different. We don't want to have to do this difference quotient 8 times when we're filling in a table of the velocity of 3, 4, 5, 6, 7, 8, how many ever 8 times, right? If we find the function, the table's much easier to fill in because evaluating a function is much easier than continuously evaluating a limit. All right, another kind of long one. I'll do better in the future, make them shorter, make them more succinct, maybe. We'll see. You're going to love Chapter 11. Thanks for listening, and good luck on your chapter quiz. You've got this.